Hey friends, today I want to talk about the turnbuckle, a small tool with a long history and many practical uses. It was originally created to adjust and tension wires in construction, helping structures stay strong, but over time, it has become a familiar item at home, from hanging things and pitching tents to DIY projects you make yourself. It's fascinating how something seemingly simple can be so versatile. There's a small but important part I want to highlight: the threaded body with a round head. I'm going to use it as a part of a homemade welding machine I'm experimenting with, and I'll show you how to make the most out of it. Alright, let's get started. Next, I have a tray full of spark plugs, something many people usually associate with vehicles, but in fact, it's also an important part of the homemade welding machine I'm building. I only need one, enough for my purpose in this project, and it will help me save time while making the most of what I have on hand. With this short piece of electrical wire, we'll make a precise short connection. One end of the wire will be connected to the threaded tip of the spark plug, and the other to the threaded body. The principle is simple but important. The tip concentrates high voltage to generate the spark, while the threaded body conducts back to the ground or machine frame. Connecting the wire this way creates a complete circuit, allowing the spark plug to produce a stable, precise, and safe spark, which is crucial for a homemade welding machine. Done correctly, this setup maximizes the use of the spark plug while giving full control over the current and spark location. After completing the short connection, the next step is to use a single-phase connector to link the welding tip to the spark plug. This connector ensures a secure connection, directing current straight from the welding tip to the spark plug, so the spark is consistent and stable during welding. In my hands right now are two simple metal washers. We'll use them to secure the threaded part of the spark plug onto the round head of the other threaded rod. The washers make the connection firmer, keeping the spark plug from loosening or shifting during operation. I've also prepared a longer piece of electrical wire to connect the power source to the homemade welding machine. One end of the wire will be connected directly to the threaded rod, while the other end will attach to an alligator clip. This setup is simple yet effective, providing a stable flow of electricity from the source to the welding machine, while the alligator clip adds flexibility, making it easy to connect to other parts as needed. To ensure electrical safety, I'll use insulating tape to wrap the connection securely. This prevents short circuits, accidental contact, and leakage, while also protecting you when working with the homemade welding machine. This is a piece of PVC pipe that I've prepared in advance. It's perfect for making a handle for the homemade welding device, providing good insulation and a firm grip, making the machine safer and more comfortable to use. However, since the PVC pipe isn't the right size to secure the threaded rod inside, I'll wrap some tissue paper around the rod until it fits snugly into the pipe. This simple method ensures a firm connection, keeps the rod from loosening or shifting during use, and still provides a safe, insulated handle. To be extra careful, I'll add a little glue to the paper wrapped around the threaded rod. This helps the paper stick more securely, making the connection more stable and reducing the risk of loosening or shifting during use, while still maintaining electrical insulation and safety for the handle. Of course, using the core from a battery to make the welding tip for the homemade welder is actually very effective. From a professional perspective, the battery core conducts electricity well and is compact, allowing the current to be focused on a precise point. When applied to the homemade welding machine, it produces a stable spark, concentrated heat, and much better control compared to other raw materials. This makes the welding process more efficient, consumes less power, and is easier to handle, especially for small parts or joints requiring high precision. It's a perfect example of using readily available materials while achieving professional level effectiveness in a DIY project. And to match the structure of the homemade welding tip, I'll sharpen one end of the battery core. Sharpening it focuses the electrical current on a very small point, producing a stronger and more stable spark during welding. This is an important step to ensure the welding tip works effectively and delivers precise sparks and concentrated heat exactly where it's needed. Alright, now we'll attach the flat end of the welding tip to the remaining end of the single-phase connector, completing the connection between the spark plug and the welding tip. Once this step is done, the electrical circuit runs continuously from the power source, through the threaded rod, the spark plug, and to the welding tip, ready to produce a stable spark during welding. We'll make another tool, a piece of electrical wire with both ends connected to two alligator clips. This tool will be connected to the negative terminal of the power source, completing the circuit and helping the welding process run more steadily. The two alligator clips also provide flexibility, making it easy to attach to the metal parts that need welding. Since I forgot to charge the battery, I'll also show you how to use a dedicated drill battery as the power source. This battery has suitable specifications, providing enough current to safely test the homemade welding machine. It's a great way to make use of available materials, convenient and safe for the assembly and testing process. Using these two metal rings will serve as an intermediary to connect the power from the battery to the homemade welding device. They help provide a stable current and keep the wire ends secure, preventing looseness or poor contact during welding. Everything is now set up, the connections are secure, and the circuit is complete. It's time to see how this device performs. Next, I'll run a few small tests so you can accurately assess the device's performance. Let's enjoy the process together. All the small tests just now were successful, showing that the homemade welding machine works steadily and effectively. Through this process, I hope you've seen how simple materials can be used to create a useful device, and also gained a clear understanding of each assembly step and the machine's working principle. If you found this video helpful, don't forget to like and subscribe so you won't miss the next DIY tips.